Hello dear students. In the last two videos we discussed about what is Gauss law, the proof of Gauss law, what are the applications of Gauss law, what are the steps to be followed to calculate the electric field using Gauss law, and in the last slide we discussed about the electric field due to infinitely charged conductor. Okay, here we are going to discuss about the electric field due to infinite plane sheet. The distribution we have taken another type of distribution, it is in a plane sheet. Infinite plane sheet. What is infinite plane sheet? The plane sheet, when compared to the distance of the electric field, it is very big. Okay. Suppose consider this board as a plane sheet. Okay. I have to calculate the electric field at this particular point. Okay. So when compared to this sheet, this point distance is very small. So I can say this sheet is an infinite plane sheet. Okay. So similar steps, whatever we have done in the infinite large conductor, we are going to do here the same steps for the plane sheet. Okay. So as I already told, since it is distributed uniformly, the charges are distributed uniformly, we have to take the charge density. Okay. That point you have to always keep it in mind. So the first step we are going to do is, what is the first step? Before that, let us consider a plane sheet. Okay. Consider a plane sheet. Consider a plane sheet where the charges are distributed uniformly like this. Okay. Charges are distributed uniformly like this. So first step, what is the first step? Yes, the first step is we have to consider the Gaussian surface. Okay. We have to consider the Gaussian surface. That is the first step. So here we are also going to select the cylindrical surface, but the surface is fitted in the sheet. Okay, the surface is fitted in the sheet. I'll give you an example. Consider this is a plane surface. Okay. Now what I am going to do is, I am going to select a Gaussian surface which is fitted in this sheet. Okay, which is fitted like this. Understood? In the sheet la in the Gaussian surface, a cylindrical Gaussian surface na fit pannirken. This is the construction. Okay, you keep it in mind. So this is my Gaussian surface. That is also a cylindrical Gaussian surface. Okay. I have selected a cylindrical Gaussian surface. As you all know, cylindrical surfaces has totally three surfaces. One is the curved surface, one is the that means top flat and bottom flat. Here one for flat 1 and flat 2. We can take it as flat surface 1 and flat surface 2. Okay. Now let us discuss about the surface. What about the surfaces? Okay. So let us take the electric field. Okay. What will be the electric field? In the sheet you consider, I am taking this sheet. Yeah. The sheet இப்படி வச்சு consider பண்ணிக்கோங்க. இந்த மாதிரி எடுத்துக்கிறோம். Okay. So the electric field will be இப்படி போகும், இப்படி போகும். This is the shape of the electric field in case of sheet. Sheetக்கு எப்பவுமே electric field எப்படி இருக்கும்னா, அந்த brushல tooth brushல bristles இருக்கும் இல்லையா, அந்த மாதிரி தான் இருக்கும். இப்படி இப்படி இருக்கும். Okay. In case of long conductor like bottle bristles எப்படி இருக்கும் அந்த மாதிரி இருக்கும். இதுக்கு எப்படி இருக்கும், tooth brush bristles மாதிரி இருக்கும். சரியா? So the bristles will be like this. So this is your electric field direction. Okay. This is the direction of the electric field. Okay. So let us consider the area vector. For this curved surface, let us take this area. Okay. When you take this area, what about my area vector? This is my area vector. What is the direction of the electric field here? This is the direction of the electric field here. I am going to find out the charge at this electric field at this point P. Okay. In the point la da electric field na finally கண்டுபிடிக்க போறேன். Okay. So in the curved surface எடுத்தனா electric field இப்படி இருக்கு. உன்னோட area vector it is in this direction. Okay. So what about this? At each point, okay, the theta angle between the electric field and the area vector is what? எந்த இடத்துல நீங்க எடுத்தாலும் எப்படி தான் இருக்கும். இந்த இடத்துல எடுத்தீங்கனாலும் area vector it will be like this. Electric field is like this. So it is 90 degrees. So at each point for curved surface, at each point, okay, at each point theta equal to what? 90 degree. Similarly, when you consider the flat surfaces, this is the flat surface and this is your area. இந்த மாதிரி இருக்கு இல்லையா, இப்படி இருக்கு. இதான் சிலிண்டர்னு வச்சுக்கோங்க. This is your flat surface. So this is the area vector. உன்னோட area vector இப்படி தான் இருக்கும். இந்த surfacesக்கு இதுல area எடுப்ப உன்னோட area vector இப்படி இருக்கும். இதுக்கு எப்படி இருக்கும்? இந்த சைடுல இருக்கும். So area vector is in this direction and the electric field is also in the same direction. So what about the flat surface? At any point theta will become what? ரெண்டுமே ஒரே directionல இருக்கு. So theta will become 0 degree. Okay. Similarly, at the curved surface at any point the electric field will also be same. Okay, for curved surface electric field is same at any point. This is about the surface symmetry. இந்த surface ஓட symmetry பத்தி இந்த மாதிரி சொல்றோம். சரி, electric field at the flat surface. So the flat surface the electric field எந்த இடத்துல நீங்க பாத்தீங்க அப்படினாலும் சேம் ஆ தான் இருக்கும். Okay, now let us go for the calculation. Okay, let us move for the calculation one by one. Okay, so the next step is to calculate closed integral of E dot dA. Okay, so we know that to calculate this we have three surfaces. To integral E dot dA can be divided into three surfaces. This can also be written as E dA cos theta. Okay, E dA cos theta. So we can write it as E dA cos theta can be split into for curved surface E dA cos theta. Similarly for the flat surface 1, okay, E dA cos theta. Similarly for the flat surface 2, okay, E dA cos theta. Okay, know that for the curved surface, first take the curved surface. For the curved surface, what is the angle between dA and E? For this curved surface, what is the angle? It is nothing but 90 degree. So when you substitute 90 degree here, cos 90, what happens? This will become 0. Okay, this term becomes 0. Then come to the flat surface. In the flat surface, both the electric field and the direction, that is area vector, are in the same direction. So what about the angle? Here the angle is 0. So here it is cos 0. It is cos 0. Okay, cos 0, cos 0. So what happens? Cos 0 is 1. So this term becomes 0 and this term becomes integral E dA plus integral E dA. Why? Because cos 0 becomes 1. Okay. Now what I am going to do is, in both these terms we can say that this E is constant. Why? Because E in the flat surface E is constant at every point. எந்த பாயிண்ட்ல பாத்தீங்கனாலும் E உனக்கு சேமா தான் இருக்கும். சரியா? அதனால we can take it as E as a constant. So dA plus dA. Okay, take E outside. So E and D we can take it as we can add these two values. We can take it as integral dA. Okay, so what is this dA actually? What is this dA? dA, let us keep this dA as it is, because it is easy to cancel. So we can keep this integral dA can be written as what? What is the integration of dA? A. So we can keep it like this. So this is what? E dot dA. E dot dA is equal to 2 into EA. Okay, the second step over. What is our third step? Find out the charge inside the surface. Okay, that is the third step. Charge inside the surface. Okay, charge inside the surface. Okay, so already I told that if you take an infinite plane sheet, how will you find out the charge? Charge per unit area. If it is length, you have to take it as charge per unit length. This is area. So take it as, take the value as sigma. Charge density as sigma equal to charge per unit area. So the third step is also over. Okay. Now what you can do, you can substitute it in the Gauss. From this you can write what is Q. Q equal to sigma A. Okay. So we know that what is Q also. So final step, you have to substitute in Gauss law. What is Gauss law? E dA is equal to Q by epsilon naught. What is this value? This value is equal to 2EA. Okay. What is Q? Sigma A by epsilon naught. A and A get cancelled. E is equal to sigma by 2 epsilon naught. So this is the electric field produced at this point due to this infinitely large sheet of plate. Okay. So I hope you can understand it. You are taking the Gaussian surface, you are inserting inside it, and you are dividing the surface into three surfaces. curved flat one and flat two. In curved surface, both E and DA are making an angle of 90 degrees, so this get cancelled out. Here it is making an angle of 0, so it will become what? Cos 0, 1. So adding up, we will get this value. Finally, charge inside the surface. Find out the charge density, that is Q by A. Substitute it in the Gauss theorem. You will get sigma by 2 epsilon naught. Here you can see this electric field, it doesn't depends upon the distance of the point. அதாவது எந்த பாயிண்ட்ல நீங்க இந்த electric field கண்டுபிடிக்கீங்க அப்படிங்கறது அது டிபெண்ட் பண்ணவே இல்லை. It doesn't depend. It depends upon the charge density மட்டும் தான் டிபெண்ட் பண்ணி இருக்குதே தவிர அது எந்த இடத்துல நீ கால்குலேட் பண்ண போற அப்படிங்கறத டிபெண்ட் பண்ணல. Suppose this is my infinite plane sheet. I am calculating this point. இந்த பாயிண்ட்ல electric field என்ன அப்படினு கால்குலேட் பண்றேன். I got this value sigma by 2 epsilon naught. Suppose I am taking the distance up to here. Now also whether the value changes? No. Why? Because it doesn't depends upon the distance. Whatever the distance may be. And the distance infinite irundha kuda my electric field value will be sigma by 2 epsilon naught. So you have to write a very important point. This electric field is independent of R. This electric field is independent of R. Hope you can understand this video. Once again I am telling that this Gauss law and its applications are very important topic. You can expect definitely one question from this applications of Gauss law. Thank you for watching and don't forget to subscribe the channel. Thank you.